Hi guys, I'm back and I'm going to talk about climate zones again. And this time we're going to talk about climate zones that are in kind of the middle part of chapter 7. So that's the mesothermal climate zones, the microthermal climate zones, and the polar and highland climate zones. So those are the sections in the middle of chapter 7. So I'm going to share my screen and then we'll just kind of continue to talk about the different characteristics of those climate zones. Okay, so all right, so mesothermal is the kind of moderate, or what we also sometimes call temperate climate zones of the world. So these are kind of the Goldilocks zones, the not too hot and the not too cold, the not too wet and the not too dry. And so these are kind of usually middle latitude areas, so not right at the equator, but not close to the poles. And because of that, they have some distinct seasonality, right? Because the Earth is tilted, they're going to have part of the year where they're tilted towards the Earth or towards the sun, getting more light, and part of the year where they're tilted away from the sun, getting less light. But their seasons are not extreme as is experienced by places closer to the pole where they have an extremely high amount of sunlight hours during the summer and an extremely low number of sunlight hours during the winter. So within this zone, there are three kind of distinct climates. The first one is called the Mediterranean climate, which is what's experienced by a lot of California. So you're probably familiar with this. So this is the hot, dry summer, and then the cool, wet winter. So again, this is a climate that might be totally familiar to you, and you might think that this is a pretty normal climate, but in fact, this is quite unusual for most parts of the world to have the warm season when plenty of sunlight is available, which most plants need to grow, to correlate with the dry time of year where there's no water. So plants get the sunlight when there's no water, and then in the other half of the year, when there is water, then there's no sunlight. So this is a challenge for many kinds of organisms, and we'll talk about that more later when we get to the kind of biome discussion. But that's the Mediterranean climate experienced in places like California in the Mediterranean. Then we have what's called the humid subtropical zone. So this would be like the US Southeast. And this is kind of another temperate climate, but because of a difference in position relative to ocean currents in particular, this is kind of going to be a wetter zone year round. So they get much more summer humidity and summer rainfall, unlike in the Mediterranean climates. And then finally, we have the marine west coast zone. And so this is a zone that's actually a little bit higher in latitude than the other mesothermal zones. So getting farther away from the equator, more towards a latitude where we might find microthermal zones, cold climate zones. But because these zones are close to coastlines, they have the maritime influence, or basically the moderating influence of the ocean, which we know allows areas to kind of be cooler in the summer as the water absorbs energy from the environment during the hot summer season, and then slowly releases that water or that energy back to the environment during the winter time. So kind of a more year-round precipitation, more mild summer than in the other zones, and probably a cooler winter, but not an extremely cold winter. So this would be someplace like Seattle or Vancouver. Okay, so here's our mesothermal maps of the world. And so hopefully you can start to recognize some patterns of where these things exist. So first of all, we're no longer on the equator. We're moving even beyond the areas where we saw the deserts in those 30-degree approximate latitude high pressure zones. So we're moving a little beyond those subtropical high pressure zones. And we're kind of in between the subtropical high pressure zones and the approximately 60-degree subpolar low pressure zones. So not too dry, not too wet, not too hot, not too cold. And then we can see humid subtropical areas shown in these darker green colors. And you might notice that these, first of all, are all, again, a little beyond the deserts. And unfortunately, this map does not have latitude on it, but I can tell you these are all about 40-degree latitude. And then the darker green areas are usually shown on a particular coast of continents. So think about that, which is different than the Mediterranean climates and the marine west coast climates, which are usually shown on the opposite coast of climate or coast of continents, right? The humid subtropical along the east coast, where you might remember we tend to have more warm water currents. And then the marine west coast and the Mediterranean on the opposite side, where we tend to have these cold water currents. So different climates at similar latitudes being affected by the patterns of the winds and the ocean currents as well. Okay, so first of all, we'll talk about the Mediterranean zone. And again, this is a climate that we're very familiar with in California, but you could also experience this zone if you lived in Spain or North Africa or Italy or South Africa or Western Australia or Chile, places in South America as well. So these zones, as we've already said, are characterized by overall moderate climate, not too hot, not too cold, but then this distinct seasonal rain pattern where we have a big lack of rain in the summertime. And as you may have experienced around here, we may go like 3 or 4 months with no rain at all. So organisms have to be adapted to deal with that lack of water during that seasonal part of the year. And in the bottom, we can see photographs of outside the San Francisco Bay Area. So that's a kind of open area that we're familiar with. And then on the right, that is a picture that looks like it could be part of California, kind of a California foothills or coast range area. But in fact, that's a picture of Spain, outside Sevilla, Spain. So those two pictures correlate with the two graphs on top, and they look very similar in part because they have very similar Mediterranean type climates. So the next climate is the humid subtropical climate. And like all these climates, there's of course some variation within this, some hotter, some cooler, some wetter, some drier areas. But as we said, the US's southeast is kind of a classic example of what this humid subtropical climate would look like. So they have these wetter summers because they have, again, correlation or proximity to these warmer ocean currents. Like all areas around this latitude, they kind of shift throughout the year of sitting closer to kind of the subtropical high pressure zone and then in the summer and then farther away from that in the winter. So there is some seasonality, certainly in terms of temperature, but the precipitation is much more consistent throughout the year, getting like maybe about 10 inches of rain a year, in each month. And then we can see that's quite different when we look at the past Mediterranean climate, where there's this big drop off and there's almost no rain, or maybe 1 inch of rain on average in those kind of summer months. So that's a distinction. And so those areas are going to be a lot greener in the summertime. Okay, and then finally the Marine West Coast Zone. So the Marine West Coast Zone is a zone that you have experienced if you've been to places like Seattle or Vancouver, or places like England. And in this case, as we already said, the ocean acts as a big moderating impact. The specific heat of the water is able to capture, essentially steal energy from the environment in the summer, keeping it more mild, and then slow release that energy back into the environment in the wintertime, keeping it more mild in the winter. So there is a seasonality here where it's drier in the summer and warmer in the summer and cooler in the winter and wetter in the winter, but it's not as extreme as we would see in places like California. So this is a picture of the Seattle area. or no, sorry, this is a picture of Vancouver, which is very close to the Seattle area in British Columbia. Okay, so that brings us then to the microthermal zone. So micro means small, thermal means temperature. So smaller temperatures are lower temperatures. So these zones are distinguished from the previous zones because of their distinct freezing winter periods. So in the other zone, in the mesothermal zone, we can definitely have freezing temperatures throughout the year, but we don't have whole months where the average temperature stays below freezing. So right in Quincy, we certainly have cold nights, we have cold mornings, we have some cold days, but we certainly have temperatures even in January, even in February, where we're kind of coming up above freezing, snow's melting, and that's distinct from this microthermal zone, which would be more extreme. On the other end, the microthermal zone is also distinguished from the polar zone, which has even more extreme temperatures because it's close enough to the equator to get enough sunlight during that summertime to experience what's called a true summer. So have some summer temperatures that get up above 50 degrees Fahrenheit. And that allows much more efficient plant growth and kind of just organismal biological activity. So these microthermal zones are farther away from the sun. They're also approaching the low pressure zones, the subpolar low pressure zones, which we already know are a little stormier and a little wetter. And there's going to be lots of precipitation here because they're in these stormy low pressure zones, but there's not a lot of sunlight, so there's not a lot of evaporation of that water. And so these are going to be kind of cooler and wetter type of climates. So within these areas, there's two subclimates. The first one is called the continental climate. So the continental climate would exist at a similar latitude to the marine west coast zone, so maybe like 50 degrees or even approaching 60 degrees latitude, but they're inland away from the ocean, so they don't have that moderating influence and therefore have much more extreme seasons. So a severe winter, and however, they do have a warmer summer relative to the next zone within the microthermal area, which is called the SubArctic zone. So this would be even farther up, higher in latitude, places like the Yukon. And this area is going to have an even shorter growing season, even less contact with sunlight, even cooler kind of summer conditions. So here's our map. And then within these two zones, we have some hotter and cooler zones, but we'll just kind of lump them together. So we have these kind of light blue zones that are the continental zones, and you can see those are a little bit lower in latitude. They have then subarctic zones, which are a little higher in latitude. Okay. And then you can see that these kind of dominate in the northern hemisphere, and we don't really see these much in the southern hemisphere. So you may already know why that is, but what we see is that in the southern hemisphere, there's very much less continental mass. And so the areas of the globe in the southern hemisphere that are at a similar latitude to these zones that we see shown in blue on this map, which is like around the zone of like 60 plus degrees latitude, are actually just covered by ocean in the southern hemisphere. So there's not really an area of land to experience this type of climate in the southern hemisphere. That's why we only see it in the upper part of the map. Okay, so microthermal climate is going to have an extreme temperature seasonality. So you can see these purple lines showing temperature going way up in the summer and way down in the winter to way below freezing in the wintertime. There's also some seasonality. There's actually some more rain in the summertime here than in the wintertime here. Okay, because remember, our climate of the dry summers is kind of an anomalous and unusual climate. And this is the continental type of climate that we might see in places like Moscow or places like Russia, also places in Europe, places in Canada, etc. Okay, then we have the subarctic zone. So this would be like farther up in Canada, farther up in Siberia, farther up in Scandinavia. And we see a similar climate pattern of warmer in the summer, a little bit wetter in the summer, drier in the winter. But this purple line is just going much lower in the wintertime. So just like a much more extreme one seasonal difference in general, and just like colder winter temperatures. So these temperatures are dropping down to like -23 or degrees Celsius or -10 degrees Fahrenheit in this picture, where it's only going down to about -20. Oh, that's kind of different. Anyway, extreme seasonal differences. Okay, so plugging along, our next zone that we want to talk about is the polar zone. So this is, surprise, surprise, near the poles. Okay, so we already know that because the Earth is curved, even in the summertime, when the Earth's axis is tilted a little towards the sun, these areas are curved away from the Earth in such a way that they're always getting hit with sunlight at an extreme angle, and therefore having a very low concentration of solar energy on the ground, which causes the temperatures in these areas to remain cold, even in the summer when they have long hours of sunlight. We also know that these areas near the poles have generally higher pressure zones, so they're generally going to be less stormy than the areas in the microthermal zones a little bit farther south. And so they're not going to be as much new precipitation. But again, these areas often look icy and snowy because it's so cold there that the precipitation that has fallen usually sticks around for a long time. So we often have the perception that they might be snowier and stormier than in fact they are. Okay, so within the polar zone, there's two subcategories. The area that's a little farther from the poles is called the tundra zone. So this would be an area that would be experienced in like northern Alaska, places like Fairbanks. And these areas are far enough away from the poles that they actually get enough sunlight to go above freezing for periods in the summer. So they do actually have snow melt out in the summertime. And that is distinct from the areas all the way at the pole, so all the way at Antarctica or all the way up in the kind of Arctic Sea, where it is totally freezing even in the summertime. Even when they're getting blasted with sunlight for 24 hours a day, the quality of that sunlight, the concentration of that sunlight because of its angle is so low that the ice and snow never melts off from those areas. So those are two distinct climates. So here's a map of these areas. And interestingly, this map kind of combines the polar climates, which we can see all the way up in northern Canada, all the way up in northern Siberia, all the way up in Greenland, and all the way down in Antarctica. But then also we see some areas at lower latitudes that have this kind of ice cap type of climate. And those are areas of the world that are way, way up high in the mountains. So we can see kind of the Himalayan mountains. We can see areas of volcanoes, like where Mount Kilimanjaro exists in Africa. We can see the Andes Mountains in South America, the Alps in Europe, the Rocky Mountains in North America, other volcanic ranges in Central America. And these areas are so high up above sea level, right, that there is so few atmospheric molecules pushing into each other, the temperature is so low that they maintain ice and snow even in the summer times, and even though they're at lower latitudes. So we've all seen pictures of these high snowy mountains, places like Mount Everest, and they're very cold even in the summertime. So they experience actually a very similar climate to the North Pole or the South Pole. And so we group them in the same similar climate zone, even though they experience that climate because of different physical reasons. So unfortunately, the textbook doesn't actually show those same kind of climate, precipitation, and temperature graphs for the tundra or for the ice caps. but we would see that we'd have temperatures that were overall lower with seasonal shifts where it's warmer in the summer, colder in the winter, and then again, actually fairly low precipitation throughout the year compared to the microthermal zones that we saw last. Okay, so just to kind of re-emphasize, the sixth major Köppen climate zone is called the Highland Zone, and we're not going to look at this zone separately or talk about this zone totally separately because, as we just mentioned, it's so similar to the polar zone. It's so cold there persistently throughout the year, and in this case, it's because of the high altitude instead of the high latitude. But basically what we can see if we climb a mountain is that we go through similar climate zones and also similar changes in vegetation that we do if we were hiking over a much longer distance, but hike kind of from the middle latitudes up towards the poles, where we would see rain and seasons and forests, and then we would go up and we would hit a much colder climate, which was much more like a tundra vegetation, and then we would eventually get up into the ice and snow. So this kind of mimics that kind of change, and that's why we kind of group them in the same category. Okay, so here's some more pictures showing kind of the tree line in the mountains, showing this difference from where it's kind of rainy and warm enough to support trees, and then the tree line above that where it's too cold. And then like way up high in the mountains where it's always snowy, and then kind of an alpine tundra type of image in the bottom. So we'll come back to this when we talk about biomes, but thought I would just kind of illustrate this change for you. Okay, so that's the end of our discussion of chapter 7. The last section of chapter 7 is about climate change. And we're going to come back and talk about climate change at the end of the semester once we have a little bit more information about ecosystems under our belt and also geology, because there's feedbacks between geology and climate. So even though we're talking about climate zones now, we're going to wait and we're going to talk about those impacts to climate zones and climates all over the world at the end of the semester. Okay, have a nice afternoon, everybody.